Welcome to you all to this MOOCs online video course Theory of Yarn Structure. We were discussing module 4 in the last two classes. Module 4 speaks on helical model of fibers in yarn. So, in the last two classes we tried to solve three problems on yarn structure under helical model. The first problem was associated to how to determine number of fibers present in yarn cross section. So, that we have solved, and then second problem was to explain the phenomenon of yarn retraction scientifically. So, we studied a theoretical model for that purpose, and also third important, how to find out limit of twisting theoretically. So, that also we have solved. Then we continued with one numerical problem that we learned in the last class. Today we will learn two more numerical problems on module 4, then this module will be completed. So, let us start with the numerical problem 2. So, numerical problem 2 reads as follows: a cotton carded ring spun yarn of 29.5 text count and 719.43 meter inverse twist is prepared. Estimate the retraction of the yarn. Right. So, we have to estimate retraction of the yarn. What is yarn retraction? Yarn retraction we have already learned in the previous class, 1 minus square 1 plus kappa squared minus 1, right. So, this is yarn retraction, this is kappa yarn twist intensity, this is also kappa yarn twist intensity. So, we have to determine yarn twist intensity, then we will be able to solve the problem. Pi d z. Okay. Twist is given 719.43, d is not given, so we need to calculate d. Z. Pi is well known, 3.14, capital T 29.5 text is given, rho cotton fiber, so 1520 kg per meter cube, Z is given, mu is not given, rest all are given. So, we need to find out mu. How will you find out mu? You will use the formula learned in module 3. So, cotton carded yarn 9.61 into 10 to the power minus 8, Z is given 709.43 squared, and T is also given 29.5, isn't it? So, this we have already solved. You will find out, if you solve, mu is equal to 0.46. So, this mu you will substitute here. So, then you will find out kappa for T is 29.5, 3.14, mu we determined 0.46, and cotton fiber 1520 kg per meter cube. So, this will give you in millimeter, and then 719.43 divided by 1000 will also give you in millimeter inverse. So, if you solve, you will find out this value 0.5236, right. So, if you know kappa, you will be able to determine yarn retraction 2 by kappa square 1 plus kappa square minus 1. So, you substitute this value of kappa, then you will find out the value will be 1 minus 0.9395, this will be equal to 0.0605. So, 6.05% will be the retraction. So, this is the answer. So, what we did, let me tell you once again. We know yarn retraction is equal to this expression where kappa is pi times d times z, yarn twist intensity. Now, what is d? D is 4 root over square root of 4t by pi mu rho. Now, in this expression capital T is given, rho is given, z is also given, mu is not given. So, we determine mu from this expression that we learnt in module 3. Q is given, cotton carded rings per yarn, so 9.61 into 10 to the power minus 8. Z is already given 719.43, T 29.5. So, if you find out, then you will solve for mu, you will get mu is equal to 0.46. This mu you substitute here. So, you substitute mu here, and then finally, you obtain kappa, yarn twist intensity 0.5236, and then finally, yarn retraction is 1 minus this. So, kappa you substitute, you will get 0.0605 as the answer for yarn retraction. Right. Now, the third problem is related to two terminologies. Third problem is related to two terminologies. Let us tell you this. Yarn retraction and yarn contraction. Actually, what happens is that though we prefer the phrase yarn retraction, some authors prefer the phrase yarn contraction. They are not same, but they are related. So, let it be clarified what is yarn contraction and how is yarn contraction related to yarn retraction. Yarn contraction is defined by length of zero twist yarn by length of twisted yarn. So, let us use the symbol C for yarn retraction. Now, if you go back to our symbolism in this module, length of zero twist yarn zeta naught and length of twisted one zeta. So, as per this definition, yarn contraction is related to this. And what is yarn retraction? Yarn retraction is 1 minus final length by original length, right. So, what is the relation between yarn retraction and yarn contraction? So, this is the relation between yarn retraction and yarn contraction. Let us write it in some other form. So, yarn contraction is equal to 1 divided by 1 minus yarn retraction. Right. Now, we come back to our problem 3. Derive C is equal to this. Derive C is equal to this. What do you know? Given by now you know that C is equal to this, and also what you know? Is not it? So, what do you do? Let us substitute delta in this expression. So, C 1 by 1 minus cos beta d by 1 plus cos beta d. So, 1 plus cos beta d by 2 cos beta d, right. So, this half into 1 plus 1 by cos beta d sec beta d. Clear? So, this problem 3 was basically to understand the relationship between yarn contraction and yarn retraction. Why we need to understand? Because although in this module we preferred yarn retraction, however, many authors in many books use the term yarn contraction. So, it is necessary for us to also learn yarn contraction and their relationship. Now, yarn contraction is defined by length of 0 twist yarn by length of twisted yarn. So, that is as per our symbolism, capital C yarn contraction is equal to zeta naught by zeta. Now, we know yarn retraction is 1 minus zeta by zeta naught. So, if we substitute, then finally we obtain yarn contraction is equal to 1 minus 1 by yarn contraction is equal to 1 divided by 1 minus yarn retraction. Then we solve the problem number 3, derive this expression. We know C is equal to this and delta is equal to this. Then by substitution we can obtain C is equal to this. So, this is the answer to this problem. All right. So, we have solved 3 problems in this module, and this module 4 ends here. Thank you for your attention.